Hey math enthusiast. In this video, I'd like to answer the question of what exactly is trig, or in other words, trigonometry. First thing you got to know is that it has to deal with a comparison of two items, or as we like to describe it in math, it has to deal with ratios. And what goes hand in hand with ratios are proportions. And we'll get to that in a minute. But what exactly am I comparing when I'm using trig? So trigonometry has to deal specifically with right triangles. So let's think of a basic example where besides my right angle, I have two angles that measure 45 degrees. So in this case, I specifically have a right isosceles triangle. So that means that if this left side is 6 units, this bottom side is 6 units. If this left side is 13 units, this bottom side is 13 units. So we can clearly see those two side lengths have a ratio of 1 to 1. Or it could be written out as like a fraction, 1 to 1. Let's take a look at another example. So in this right triangle, my other two angles measure 30 and 60. So let's say I label this short side as being 4 units long. Then I know the hypotenuse, the long side, is going to be 8. If that short side was 7 units long, I know the long side, the hypotenuse, would be 14. So we can clearly see a relationship here where my ratio comparing that short side to the hypotenuse is now 1 to 2 instead, or 1 over 2. So the question then becomes, how do I know these shortcuts and what exactly do they have to do with trig? So there's 3 functions, basic trig functions, that tell me what these shortcuts exactly are. So the first one I want to mention is the tangent function of 45 degrees. You might recognize that 45 from our first triangle. Now, if I were to plug that into the calculator, what I'm going to get is 1. So that's telling me what the ratio is between these two side lengths. Now, if I were to use a different function, let's say sine, and plug in 30 degrees, that should sound familiar because that came from our second triangle. The ratio that's going to give me is 0.5 or 1 over 2. And now we can see that's the comparison between this short side and the hypotenuse. So what these trig functions are giving me are shortcuts, or allowing me to solve for missing side lengths. Now these cases are easy, so let's try something a little bit more complicated. Now this right triangle looks a lot like the first right triangle I saw, but now this angle is 37 degrees. We have 8 on the left side, and I'm looking for this bottom side. So if you remember earlier, we figured out that tangent of 45 was equal to 1. Using this tangent function again, but plugging in 37, I end up with 0.7536. Well, how is that going to help me solve for x? Well, remember, this is all a ratio, a comparison of two values. So technically this 0.7536 is written over 1. And according to the definition of this function, I can set this ratio equal to the comparison of these two side lengths, 8 over x. From there, I can actually use that information to help me solve for x. So that missing side length is actually going to be 10.6. So using this simple shortcut here, this tangent of 37 degrees, I was able to solve for that missing side length. The purpose of trig is to use these shortcuts to find missing pieces in right triangles. Now I know your follow-up question is going to be, well, how do I decide? You use tangent, but what function do I use and when? Well, that's a question for another video, but the important part that you understand is that each of these functions relates to a different ratio. If you notice in the example I used up above, it had nothing to do with this third side, the hypotenuse, which is used in these other two functions. Now, it may seem very foreign at this point, especially with terms like sine, cosine, and tangent. But what I want you to understand is that each of them are shortcuts. They tell me what the comparison is between two side lengths. Is it 1 to 1? Is it 1 to 2? Is it 0.7536 to 1? And I can use those shortcuts to help me solve for missing parts.